Okay, shift registers. So, there's kind of two types of shift register you need to know in there. Okay, what are they called? PISO and CPO. So which one is this one, do you think?
CPO.
It is, because we've got data coming in here, and we've got in a serial fashion, so you're going to have 1, 0, 1, 1, 0, whatever coming into here, then it's going to be presented in a parallel form up here. So this is what's called a serial in, parallel out shift register. Okay? Things you need to notice, don't get them confused with counters, because they don't do that thing where it goes around like that. We link each shift register to the next one from the output Q to the input D, from the output Q to the input D. We then need to connect all the clocks together. So each time we pulse the clock, data is moved along the registers. So this would take 4 clock pulses to fill, wouldn't it?
Yeah.
Okay, so the data would come in, would take 4 clock pulses to 4 clock pulses to fill, but only 1 really to empty. Okay, the data will be waiting on the parallel outputs there, and then we've also got the reset to clear it as well, to start again. So an example of this would be something like a Sky TV dish. You'd have the data coming in. First of all, it's going to be all distorted and attenuated. What else would it pick up? Noise. So what would we put it through to regenerate it?
Schmidt trigger.
Yeah, so it goes through a Schmidt trigger, gets tidied up into a nice, neat bit of digital information. It's fed in 1 bit at a time, and then comes out of this as a parallel output, which can then go into a digital to analog converter and be converted into an analog signal. Okay, so it's all part of that. Okay, so clocks are all connected together, resets are all connected together, dead easy to remember. What we need to be able to do is the timing diagrams for it. So, if we look at something like this, we'll do this one together. We need to look at, here is the data input coming in. It only gets loaded into QA on the rising edge of the clock pulse, because they're made out of D-type flip-flops. Okay, so on the rising edge of the clock pulse, whatever data is here is transferred to QA, but also in each clock pulse, data is copied down to the next shift register. So on the first line we look here, so we're going to go up there because it's a logic 1. Look at the next clock pulse, it's going to stay up there because it's a logic 1. Look at the next clock pulse, it's going to stay there because it's a logic 1. But here we've got a logic 0, so it's going to go down. Here we've got a logic 0, so it stays down. Here we've got a logic 1, so it goes up. Here we've got a logic 1, so it stays up. Here we've got a logic 0, so it's going to go down there. Do you agree with that? Okay, so now we just need to then look at this and move it 1 clock pulse to the right each time the clock pulse happens. So here, 1 clock pulse is that long, so just remember that it's 2 little blocks. I'm making a video, so. We need to then mean that this pattern here needs to move along by 2 blocks. So we just go along here, that's 2 blocks later, go up like that, go down 2 blocks later. This one needs to go up there, go up like that. Does that look right? So we're going down like that. Okay? And then this one you just do 2 again. Like that. That's gone to there like that. And then this one is going like that. Okay, and down to there like that. So they're going diagonally 2 blocks to the right. Okay? So you need to know how to do this, transfer that to that, and then just shift it one whole clock pulse to the right each time.
So it is how much you move it over by dictated by the rising edges, the distance between.
Yeah, that's one clock pulse
Okay.
timing. So this is CPO. Okay, so that's how you do those. Then, the other one we have to look at is a little bit more complicated. This is the piezo shift register, paralleling serial out. This time we provide, well, where would you find a piezo shift register?
Receiver.
Yeah, great, the receiver of the PCM system. That's because the receiver's going to, it's in the transmitter. Sorry, not the receiver.
Oh
Let's not get the wrong way around. It's in the transmitter because the DAC the ADC produces a parallel output, and then it needs to be squeezed into a serial output to be sent down the transmission link, doesn't it? Okay. So that means we can put data waiting at the parallel input. I don't know, if you had 1, 0, 1, 0 there. What we need to do is, the problem is set on these D-type flip-flops overrides anything else. Okay, it doesn't need any kind of clock pulse to load the data into Q, into the D-type flip-flops. So the reason we have these AND gates is to make it so we can pulse the load line like that, and when this then goes to a 1 here, then you've got a 1 and a 1 here, so that would become a 1, which would make that a 1. This one here would have a 0 and a 1, so that would still be a 0, so that wouldn't load into it, wouldn't set it. Okay? And so therefore you can, by pulsing the clock pulse, it effectively loads whatever's in here into the D-type flip-flops. Then we can pulse the clock. How many times would we need to pulse it? 4 times, and it would empty the shift register coming out of the serial output. So it goes, come, one load of data goes in, and then and feeds it out. And that's why this clock needs to go in this case 4 times faster than that clock, doesn't it? Yeah? If it was a 16-bit shift register, it'd have to go 16 times faster, wouldn't it? To empty it, and that's why those 2 clocks have to run n times faster in the piezo shift registers. Okay, so let's just do an example of this. Okay, first of all we have to decide the data. So we'll do that 1 0 1 0. Okay, so D0 is a 0. Okay, so we're doing 0 1. Oh no, we're doing 1 0 1 0. So let's go the right way around. This is always a little bit where it gets a bit confusing. So we're loading 1 0 1 0 into it. This is that's A, B, C, D. Checking that. Yeah, A, B, C, and D. That's the right way around. So, looking at this now, first thing we have to do here is we clear all the shift registers. So, these are at a 1 already, that's at a 1, that's at a 0, that's at a 1, so that's just showing that. So when we get to this first clock pulse, it's going to go 0, 0, 0, 0. Then it waits, sorry, went too far there, do that again. There's the reset pulse, so it's going to reset there rather than there. So reset there.
Why did we start high?
I don't know, it's just because that's the residual data that's in the shift register. Yeah, so it's like you need to clear it.
Did the other one start high as well? Did the CPO start high?
No, it depends when you empty the CPO, it depends what you connect to the input first. That depends, it just watch out for it. If it does start high, it's just to show you understand what the reset does. So then we need to load here, so we're going to go along to here, and we're going to load the shift register with the data. So it was 1010, wasn't it? we're going to load into it. So A is a 0, so therefore when we load here, it's going to stay 0. And we'll go on to the next clock pulse. This one's going to go up to a 1 at the load point here. This one is going to go to a 0, stay at a 0, and this one is going to go to a 1. Oops. Don't like that, it's gone on there.
Is that backwards then, Joe? Is there one at the bottom? If you write out, is it 1, 0?
Yeah, it's 1. We're going, because this is QA, and that's A, isn't it? Yeah. For some reason, Windows has just ruined the day.
You have to put your mouse at the top of the taskbar.
Here.
At the very top. There you go.
Oh, it's broken up. Just move it.
Scroll down.
Let me scroll. Kind of there. So what we need to do now, once we get to the first clock pulse, is we need to move whatever is here down to here. So at the first clock pulse we're at 0, so that needs to go to here, like that. Okay, so that means that will go to 0. That needs to go to there, so that means that will go up, because that's going to there. Now this is already down, isn't it? So we're going to go there to there, so that will stay low.
That one should be up, shouldn't it?
Which one?
The bottom one. Because D's 1.
These are 1. Oh yeah, 0, 1. Yeah, sorry. It should be down there, yeah. Get a bit. It's going to be the worst video ever. Right. So we've got loaded in here 0, 1, 0, 1 there. So that should be just that's where Windows put me wrong. But that's going to go to there. So that's going to go down like that. With me? So we just move it along. It appears not to work whilst you're doing it. It appears a bit weird. But it actually does after a while. Now this is just going to have 0 fed into it now. So we can just carry on like that. Looking at the next one, 0 is going to go to there. Because that one's going to go to here. This one's going to go to here. That one now is going to go to here. So that means that goes down because that's gone to there. We've done all like that. That one has gone to there, but now that one needs to go to there. So we have that. And we carry on till they've all gone. 4 clock pulses basically. So we've got 1, 2, 3, 4. So this one is just having 0 fed in it, so that's just going to carry on like that. This one is now here, it's going to go to there, so that's just going to go down like that. That's going to go down like that. And then this one here is going to go to here. So that's going to go down like that. Okay? So there, you've got the 1, 0, 1, 0 that you started with at the top. Okay, but that's now come out one at a time out of QD, which is a bit, surprising how it works, but that's basically how it does it. So you're looking at moving, that has gone to there, everything moves down diagonally, like that. Okay, so it wasn't the most clearest explanation of that, but you get what I mean. Do you want me to do it again? We do one more. Well, often we could do one more again. Often you then need to show how you connect them up. So the CPO one. The other thing you need to do is these self-filling shift registers. Well, not self-filling. These ones where they feed shift registers to a logic gate, which are really easy. You just need to know the logic gates. So that's a NOR gate with a NOR. You've got your truth table is like that. So you're looking at that. a 1 and a 0 makes, if it's, this one's an OR, oh, it's an OR gate, no, we'll make it a NOR. You do it with an OR gate like that. Then we're looking at a 1 and a 0, so that's going to give a 0. Here, a 0 and a 1 is going to give a 0. A 0 and a 0 is going to give a 1. And then a 1 and a 1 is going to give a 0. Okay, so depending on the gate, you're just literally looking at them like that, comparing and putting them into there. And then it shows it's going to fill up with zeros, so that should become, like I've written here, filled up with zeros. So they're just stupidly easy, they're just a way of checking a logic gate, isn't it? And then you've got remembering how to connect up the piezo one, so you need to learn that. And then you've got the self-filling shift registers. Remember those? So these always require something like a NOR or an XNOR or a NAND gate, something that will provide a 1 on the output when you've got 2 zeros at the input. And you just go, this one is a XNOR. So we look at the pattern. A and C are both 0 when you start, so therefore the output will be here a 1 waiting here. We pulse the clock, it introduces a 1 to there. You notice that 1 moves down diagonally each time. And we just look at the one above to see what happened next. So here, because A and C are connected, A is now a 1 and C is a 0, meaning that the output now will be a 0. So we bring a 0 into here and move that there. Then we look at A and C again, and now A and C are 0, so now a 1 comes into there, move that down, we get that pattern. Then we look at A and C again, this time they're both 1s. So we get a 1 again, and that pattern moves down to the right. And you just keep repeating it. The thing to watch out for is they skip them, so sometimes it's worth just doing them on a little bit of paper to the side. Okay? So that's the self-filling shift registers. So it'll either be a NOR, an XNOR, or a NAND. So make sure you get your gates right, don't get mixed up. That's really important. Okay? And that's it with shift registers. I'll redo this one with a different number. So, this time we're going to have, I don't know, 1, 1, 0, 0. Okay? So we're going to go down to 0 here, down to 0 there, down to 0 there, down to 0 there. Go along to the load input. And we've got 1, 1, 0, 0. So that's a 0. That's a 0. That's a 1. And that's a 1. So that goes down to there. Makes that a 0. That goes down to there. Makes that a 0. That goes to there, which makes a 1. Okay? You'll see how it's going to work now. Carrying it along. That one goes down to there. That one now goes down to there. So that becomes a 0. So these all become 0 right along here. That one goes to there. That one goes to there. That one goes to there. And we've got 1, 1, 0, 0. Just like magic. Is that alright, shift registers?
Yeah. YouTube channels will be